Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 29th, 2026, about 4 days ago. It introduces the Agent Reasoning Reward Model, a new framework that moves beyond simple pass or fail rewards by providing agents with dense, structured feedback on their intermediate reasoning steps. The paper is titled, Exploring Reasoning Reward Model for Agents. And as we'll see later, the results are really impressive, showing that this detailed feedback strategy leads to state-of-the-art performance on complex benchmarks like GIA. Alright, to build a robust foundation for this method, the team curated two major datasets. Figure 1 details the distribution sources, starting with the top panel, which lists the composition of the supervised fine-tuning set. This contains about 56,000 high-quality trajectories from tasks like DeepScaler and Toolstar. Then, the bottom panel shows the reinforcement learning dataset, which is significantly larger, comprising over 700,000 samples from diverse benchmarks like MetaMath, QA, ensuring the model sees a wide variety of logic and tool use scenarios. With the data ready, Figure 2 outlines the overall training framework, which the authors call Reagent. Starting on the left, the agent takes a query and uses tools, such as a code interpreter or search engine, to formulate a response. The process revolves around the central Agent-RRM block. For the reagent C path, marked by blue arrows, the model generates a verbal critique, visible in the center, that loops back to let the agent refine its answer. In contrast, the reagent R path, shown with gray arrows, uses the scalar score of 0.32 to drive the reinforcement learning pipeline on the right. Moving to the results, Table 1 presents a comprehensive evaluation on general agent and search benchmarks. The comparison includes proprietary giants at the top and various open-source baselines in the middle. Most importantly, the bottom section details the performance of the new reagent models. Here, Reagent U with the QN38B backbone achieves 43.7% on Gaia and 46.2% on WebWalker QA. These scores clearly surpass the standard baseline, validating the unified reasoning reward approach. Following the general benchmarks, Table 2 now focuses on knowledge-intensive reasoning and mathematical reasoning. The upper rows compare results against proprietary giants in various open-source baselines. Shifting to the bottom section for our agents, the proposed methods consistently improve upon the base model. Notably, Reagent U achieves a score of 60.0 on AME24 and 76.8 on Bamboogle, demonstrating robust capabilities across diverse logical domains. Okay, determining exactly how much weight to give these reasoning rewards is critical, and Figure 3 explores this trade-off. The chart plots performance scores on the y-axis against the reward weight, lambda, on the x-axis. As we track the pink bars for X bench and the blue bars for AMN24, we see performance steadily climb as lambda increases from 0. The sweet spot appears right around 0.3 or 0.4, where both tasks reach their peak scores before dropping off. This confirms that balancing the model-based reasoning reward with standard outcome rewards is essential for optimal results. So, Figure 4 reveals the specific prompt used to generate this structured feedback data. It breaks the evaluation into 3 distinct parts. The Think section demands a comprehensive analysis of the reasoning trajectory, explicitly checking for tool misuse or unverified guesses. Then, the Critique section asks for a concise, actionable summary of errors to show the agent directly. Finally, the Score section converts that qualitative assessment into a single number between 0 and 1, providing the scalar reward for training. Well, Figure 5 demonstrates this critique mechanism in action, with a search task from the GIA benchmark. At the top, the question requires finding a catastrophes force to identify a matching nuclear test. In the first response panel, the agent stumbles, relying on ambiguous search snippets to incorrectly guess the answer is Canakin. Crucially, the critique section in the middle diagnoses this failure, noting the agent missed essential browse tool calls. Guided by this feedback, the second response at the bottom rectifies the error, using the proper tool to find the correct 15 megaton figure and solve the problem. Wrapping up, 2 takeaways stand out. First, the reagent framework proves that dense, multifaceted feedback, combining verbal critiques with scalar scores, is far more effective than simple pass-fail rewards. Second, the impressive results on benchmarks like GAIA suggest that teaching agents how to reason via detailed diagnostics is key to unlocking the next level of agentic intelligence. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.